Alright, hi guys. So today I'm going to do a quick podcast lesson on how to assign oxidation numbers and how to identify redox reactions. So, assigning oxidation numbers is pretty straightforward. You have to just know a few rules to do it. So, elements in their natural form, so anything that's an atom or a diatomic molecule is always going to have an oxidation number of 0. So something like H2, that's a diatomic molecule, and zinc, that's actually a solid metal in its elemental form. Now, ions are always equal to their charge. So something like the chlorine anion, right, is going to have an oxidation number of -1 equal to its charge. Now, the zinc cation is going to have an oxidation number equal to its charge, +2. Now, the rest of the rules are all about when we have atoms or elements combining into molecules. So of all the oxidation numbers in a neutral molecule, if it is neutral, we're going to have to equal 0. Sum of all the oxidation numbers in a molecule has to equal the total charge. So it's similar to what we saw up here. When it's no charge, it's 0. When there's a charge, it has to equal that charge. So when combined in a compound, group 1 elements are always going to be +1. Group 2 elements are always going to be +2, right? So your alkaline metals are +1, alkaline earth metals are +2. Halogens, which is group 17, is always -1. Now, the other two big rules are these two. Oxygen is going to be -2. Hydrogen is going to be +1. Right? I say usually because when you look at other types of chemistry, this is not always true. But for the purposes of regular chemistry and the chemistry SOL, it will be -2 and +1. So here I've got a couple practice problems. I'm going to shift this up. And we'll look at A, B, and C here. Right? So looking at this, when I assign A, the first thing I should notice is that this is a diatomic molecule. So its oxidation number should be 0. Okay. Now, NO2, this is a different case. Now I have a molecule. So overall, the sum of these oxidation numbers is going to have to equal this charge, -1. Oxygen is easy because it rules. Oxygen is usually -2. So each oxygen has a -2. Now there are 2 of all combined. This gives me -4. Now I don't have a rule for nitrogen, so I have to solve for X. So when I solve for X, I find that it is +3. Notice that the oxidation numbers are different when nitrogen is involved in different molecules. Okay. Now please note, these guys up here, these are oxidation numbers. Okay. These are just the total values used to calculate up the oxidation numbers. When it asks you for the oxidation number of the oxygen, you wouldn't say -4, you would say -2. Alright, in this next molecule, right, this is a neutral molecule. It is equal to 0. Hydrogen, I know, is going to be +1, so overall +2. I don't know my carbon, that's going to be an X. Oxygen is going to be -2, but there's 3 of them, so overall -6. So when I solve for X, all right, so you add 6 over here, subtract 2, I end up getting +4. So carbon is going to be +4. All right? So there are 3 additional practice problems down here at the bottom. Go ahead, pause the video, and try them on your own, and just press play again when you're ready for me to go over them. Okay, so you should have had a chance to try these on your own now. So looking at, this is the permanganate ion here, right? So it is an ion, so overall the sum is going to have to equal -1. Manganese, I don't know. It's going to be an X, right? Each oxygen is -2, so overall this is a -8. So X minus 8 equal to -1, right? That means that this is going to have to be +7. So manganese is +7. This next one's a little difficult, right? But nothing you guys can't handle. It is charged, so overall it's going to be -2. Oxygen's -2. Hydrogen is +1. I don't know my zinc, so this is X. Now the thing is, outside of the parentheses, remember this 4 distributes to each one of these. So this is going to be -2 times 4, so -8 plus 1 times 4, so +4. Okay. So X minus 8 plus 4 equals -2. That means that our X is going to be positive 2. Okay. So zinc is positive 2 here. Now this last one, right, is even more difficult. It's still a charged molecule, neutral molecule, so it's 0. Oxygen is negative 2, so overall this is minus 6. But here I've got iron, and I don't know iron. But if I'm going to solve for X, I have to account for the fact that there are 2 irons. So this isn't just X, this is 2X. Right? So when I solve this, right, 6 goes this side, divide by 2, each iron is going to be plus 3. Right? So the oxidation number of iron in that case is plus 3. Right, so hopefully that clears up some questions on assigning oxidation numbers. This is going to be pretty important for the next part, where we talk about redox reactions. So redox is short for oxidation reduction. So you get the redox, right? I don't know why it's switched, but we call it redox reactions. So a redox reaction is one in which electrons are transferred from one chemical species to another. Right, so my electrons are going from one element to a different element. Okay. So oxidation is losing electrons. It is an increase in oxidation number, right? So your oxidation number is going up, which means you are losing electrons. Okay. Reduction is gaining electrons. It is a decrease in oxidation numbers. You get it? It's a reduction in oxidation number. Right? There's an easy way to remember this because it's kind of hard with the opposing increasing, decreasing. But the first one is Leo the lion goes grr. Right? This stands for losing electrons, oxidation. This one is gaining electrons, reduction. So see, Leo the lion goes grr. Lose electron, gaining electron. If you don't like this one, there is another one called oil rig. Oil rig is oxidation is losing. And then reduction is gaining. Right? So the same thing lines up. Oxidation is losing, reduction is gaining. Right? So those are two ionic devices for you to remember what's going on. So I've got a couple examples for us to go through. All right. Let me move this up. So looking at this particular example. Here, the first step is going to assigning oxidation numbers. Okay. So H and O are that's going to be plus 1 and minus. So all this is 2. This is minus 6. The overall charge is 0. So plus 2 minus 6 means that the sulfur have to be 4. Here, okay, I've got minus 2 on this minus here, plus 1 there for each one. So this is going to have to be plus 4. Okay. Now, notice, are there any changes to any of these element oxidation numbers? Hydrogen to hydrogen is still 1. Sulfur to sulfur is still 4. Oxygen to either of these oxygens is still plus 2. So this is redox. It is not a redox reaction. Now let's take a look at something that is a redox reaction. Right. So here I've got a cation, mercury, which is going to be a plus 2, the same as its charge. Iron alone, element 0. Right. Now this is mercury, which is actually a diatomic naturally, so it is also 0. Right. And then iron, which is plus 3, so it's going to be plus 3. Okay. This is a bit of a weird example. Don't worry too much about the fact that I knew that was elemental. But looking at this, right, let's see what's happening here. The mercury from plus 2 to 0. Notice that was a reduction in oxidation number. So we will say that the Hg, right, is reduced. Now if I then look at the iron, it from 0 to plus 3, its oxidation number went up. So then the iron, right, is oxidized. So if I were to talk about electron transfers, right, if iron is being oxidized and oxidation is losing, the iron is losing its electrons and giving them to the mercury because mercury is reduced, is gaining. Right? So oxidation and reduction have to happen at the same time. Right? You can't have one without the other. Okay, let's look at another example. Okay. Here I see chromium, which I'm actually going to do down here. So chromium is +1. Right? This chromium is going to be +3. Okay. So what's going on from 1 to 3? Right? I see that that is oxidation. Right? So my chromium is oxidized. Looking at tin, he has tin. Right? It's going to be +4 to +2. That is a decrease in oxidation number, so it is reduction. Right? So my SN is reduced. Alright, now I want you to try one on your own before I go over it with you. So here's the example. Go ahead and try it on your own. Pause the video, hit play again when you're ready. Alright, so hopefully you've had a chance to try this on your own. So looking at this, okay, looking at this, I've got zinc, which is starting at 0. Then I have to consider what's going on here. So this oxygen is going to be -2, giving me an overall of -8. Right? Let's see. So this is actually really interesting. This is an ionic compound. So if I were to take out this SO4 on its own, I would recognize that as the polyatomic SO4 2-. So if this is overall 2-, right, and this is -8, that means that my sulfur would be +6. Now to balance out this -2, my zinc would then be +2. Okay, so you have to recognize your polyatomic ions here too. They don't just go away. Right? So looking at this, I went from 0 to +2. That is an increase, so the zinc was oxidized. Okay. Same thing here. I have to recognize that this entire sulfate is -2, so the copper is going to be, well, let me write it down here, +2. This copper is elemental, so it's 0. So +2 to 0, that's reduction. So copper is reduced. One more, a little easier. See how you do with this one. All right, try it on your own. Pause it. Play when you're ready. All right, so looking at this, I've got magnesium, elemental, it's 0. Oxygen, elemental, it's 0. Here, when it's a compound, oxygen is -2, magnesium group 2, so it's +2. Right, so magnesium to the magnesium, that is going, so it is oxidized. And the oxygen is going from 0 to -2. That is a reduction, so oxygen is reduced. Notice these coefficients don't matter to me at all. Alright, last one for you guys. Go ahead and try that one on your own. Okay, so arsenic, elemental, it's 0. Chlorine, elemental, it's 0. Here, chlorine is in a compound. It's a halogen, so it's going to be -1. Now overall, that gives me a -3, so my arsenic has to be +3. 0 to +3 is oxidation, 0 to -1 is reduction. So arsenic is oxidized, and chlorine is reduced. Alright, so hopefully that was helpful to you guys. If you have any questions, feel free to come and ask me after school sometime.